Okay, in our first video, we derived the general solution to the wave equation, and we can actually prove that the general solution to the wave equation is actually an arbitrary function, let's say p of x minus ct plus q of x plus ct. And for us to prove this, we'll begin by having two transport equations, actually four transport equations. We have this first forward transport equation with the backward transport equation, and we have now at this point we start with the backward transport equation and the forward transport equation. And I did some mistake. I've changed this to a minus, and also I've changed this to a minus so that the first one becomes a backward transport equation. Now, we proved also in our previous video that solving this is if you solve these two transport equation, you will have solved the wave equation. And now, the general solution to a transport equation is a function of x plus ct, of this variable plus ct. And now, this second transport equation in this case, if we solve this transport equation, we'll get a general solution. The transport equation wt minus c wx is equals to 0. If we solve it, we'll get this function w of xt to be equal to f of x plus ct as the solution. And on this other side, if you solve this forward transport equation, the second one, you will get v of xct to be equal to a function of x minus ct. Okay, now, if we've now obtained w, we can come and replace it at this particular point to get u of xct plus u of x plus u of t plus cu of x to be equal to f of x plus ct. And also this other side, we obtain what v is. We can replace v to get u of ut minus cux is equals to g of x minus ct. Now, if we add the two equations, we will obtain, like, let's say this is my first equation and this is my second equation. Okay, my 0 is not that interesting, but now if you add equation 1 and equation 2, you'll obtain 2ut to be equal to f of x plus ct plus g of x minus ct. And if we subtract the two equation 1 minus 2, you get 2cux to be equal to f of x plus ct minus g of x minus ct. Now, we can divide both sides by 2 to make ut the subject of the formula, whereby we'll get ut to be equal to 1 over 2 f of x plus ct plus 1 over 2 g of x minus ct. And in this second case, we can divide by 2c to make ux the subject of the formula. We'll have ux is equals to 1 over 2c f of x plus ct minus 1 over 2c g of x minus ct. Now, we are looking for a solution to the wave equation, right? And which is, the wave equation is utt minus c squared uxx is equals to 0, which means the solution to this equation will be u of xt. And that's what we are trying to prove. And now, for us to get u in this particular case, we just have to look for the antiderivative of ut, and we'll have gotten u. And we also look for the antiderivative of ux, and we'll in the same way have gotten t. And if the two are the same, then we'll have proved whatever we are supposed to prove in this particular case. Now, I want us to integrate these particular two equations, and so that we can obtain u of xt. And in this case, we can take capital F prime to be equal to f, and capital G prime to be equal to g, which means if we can equate g to be equal to, g will be now the integral of small g, integral of the small g, because g prime is equals to g, so g will be the integral of the small g, similar to f. Capital F will be the integral of f. So we are going to use this to integrate these two. Now, with the first one, when we integrate, we get u xt will be 1 over 2c f of x plus ct. Okay, you will realize we only have a half, and at this point we get 1 over 2c. So this particular function f of x plus ct, we see it's a function, and inside this function there's another function ct. So normally when you are differentiating, you first differentiate what is inside, then you multiply by the derivative of everything. Now when we are integrating, we will integrate what is inside ct to get a c, and then we come and divide it with the integral of everything. So c, when we divide, we'll get this 1 over 2 will now have 1 over 2c. So this is where the trick is, integrating this, and now we get 1 over 2c f of x plus ct minus 1 over 2c g of x plus ct minus ct. So this is supposed to be a plus. I think so. I think it's supposed to be a plus, yeah. No, not a plus. Actually, because when we are integrating here, we get negative c. When you divide it, it will change this particular plus here to become a negative. So it's a negative. Whatever I've written is correct. And integrating the second one with respect to x. Now, when we integrate, okay, fortunately x, there's no c near x, so we will maintain 1 over 2c. So the integral will be 1 over 2c f of x plus ct minus 1 over 2c g of x minus ct, and it's a capital G. Now, we realize that u of xt we are obtaining here is the same as u of xt we are obtaining in this second equation, which tells us that the first equation we solved and the second equation we solved, we are coming to the same solution, which is a general solution to a wave equation. Okay, so therefore the general solution to the wave equation can be written in this form. I know some of you are wondering why is the first one we started with the p of x plus ct and q of x plus ct. That's just an arbitrary function, and you can replace 1 over 2c f of these two with a function like p of x ct plus q of x minus ct, which now proves that indeed that is the general solution to the wave equation.